Alright, hello everyone. So, in this stream, we are going to start and hopefully finish implementing pivots. Now, they're probably going to be the most challenging part of this distance matching setup, but I'm going to get as far as I can in this live stream. If anyone is here who has seen the previous, who watched the previous stream, you'll know that I encountered some issues with the stops and orientation warping. I've fixed those in between the last stream and this one. Everything is working perfectly on axis. Now, off axis, instead of using orientation warping with the stops like I originally wanted to, I went for a blend between two stop animations depending on which two of the axes you're in between. So if you're going forward or right, or left, and you're between the two of them, you're going to blend between that forward stop and left stop animation. It's not perfect, there's a bit of foot sliding because of the blend, but it's actually how Epic did it in Paragon. And I want to do a bit more polishing with that, because I really don't like the foot sliding that comes with the blend on these stops. But they are still distance matched. So for the starts, I do use orientation warping. There's a bit of foot sliding at the very beginning when the legs rotate as you're blending from idle into that orientation warping stage. What Epic does to solve that is they do a blend for the first step, and then they switch to orientation warping. And I will most likely implement that approach, but I also want to try implementing the inverse to the stops, where the stops start using orientation warping, but the last step is taken with just a blend between two animations. But that's probably something, if I can get the pivots figured out during this stream, I'll probably work on polishing what I already have there on my own time, and then I'll condense all these distance matching Paragon streams into a single video on setting up distance matching with Paragon characters. So to begin, the first thing I want to do is go over the changes that I've made since the last stream and how I solved some of the issues that I was having. So, inside of the stop state, instead of using orientation warping, I'm blending with a stop blend weight variable, and I'm using two stop animations. Then these evaluators have the sequence pin exposed, and I have two variables here, a stop anim A and a stop anim B. Now, I've let myself get a little bit disorganized with this event graph, but if we go all the way down to the bottom, if acceleration is greater than 0, I simply figure out where at or which direction I'm moving in. Well, I'm taking this direction and I'm splitting it up into essentially quarters. If the direction is a circle, I'm cutting it down the middle, and then I'm cutting it horizontally to get to the 4 separate quarters of that circle of degrees. And if I'm inside, let's say, the top left circle, I blend between jog forward stop and, well, jog left stop and jog forward stop, where left stop is stop anim A and forward stop is stop animation B. It's really very similar to how I figure out the cardinal direction above. And again, it's all pretty messy, but the focus of these streams is to implement stuff fast. I'm figuring it out as I go, after all, and the video or 2 or 3 or however many it takes that I'll make on just distance matching with Paragon, which will be separate from my series on locomotion stuff with Unreal Engine 5, which will also include distance matching. I will clean up all of my logic for the video. Now that's essentially what fixed the stop state. Do not mind the motion matching node there. I was playing around with some other new features between streams, and I didn't put a lot of, and yeah, UE5 has motion matching. I've not had enough time to figure out how it works yet. So. And the other issue I was having, which I discovered after the stream, was that there was foot sliding with the starts, and I actually solved that by applying the exact same approach as the stops to the starts. Instead of using an advanced time by distance matching node, I used a distance match to target node, and I just inverted the start distance, multiplied it. So I multiplied it by -1 and fed that into the distance to target parameter. And now these starts work and they are distance matched. I'm not sure why the advanced time by distance matching node wasn't working. I might look into that sometime in the future, but for now, I probably want to stick to the distance match to target. And of course, when you're starting, you just need to invert the start distance so that it's a negative number instead of a positive number, and it will work. And I'll go ahead and play, and I will set this on slow-mo. Let's do 0.3. So as you can see, there's no more foot sliding with the starts. In slow motion, it is easier to see the orientation warping that happens at the start of the start state. So that'll be something that I will work on fixing later on, probably not during a stream. It's simple, and it's something it's probably not worth the time spent on it for the stream. The other thing that I did between the streams was I just took the blend space that came with this Paragon character for moving forward on a slope or leaning. Whoops, I keep accidentally backing out of these. Not sure why or how. And I've put that blend space here inside of the graph. Now this is an old blend space which UE5 still supports, but there is a newer way of creating a blend space where you just type in, let's see, blend space, and you can open it up and place everything in here inside the blend space in the animation graph. I'll convert this over for the video I make, but for now I'm going to use the old method just to save time. But inside this blend space, we have these forward and leaning animations, and we also have this slope and slope lean animations. And right now I'm not doing any calculations to figure out the slope that the character is moving on. That will come later, but the base animation blueprint that this Paragon character comes with does have the calculations in the event graph to determine how far the character needs to lean. So what I'm going to do is I am going to go to the animations for this Paragon character, and I am going to try and find that blend space. Here we go. Well, look at that. There's actually a blend space for all of these, and I did not even realize. Awesome. So I'm going to actually go ahead and move each of these over into the anim blueprint. And then we'll take a look at the actual logic in the event graph, because I haven't actually looked at how they calculate how far the character needs to lean, and I'm curious to see how they do it, and I want to show you guys as well. And now we are getting the final blend space, the backward blend space. And I'm going to add all of these to the jogging sync group. I have not had problems with the UE5 preview crashing so far. Trying with opening projects. Are you able to create a new project in the preview? That'll help determine where the issue might be. Actually, I take that back. I think I might have I vaguely recall running into an issue in the past. I'm not sure if it was crashing trying to open an old project or a new one, but I know I ran into some sort of odd issue in that uninstalling early access while leaving the preview installed fixed that issue. I don't like how this blend space is so much bigger. I don't know why it is. I'm going to drag another one in because that's bothering me. There. So sync group can be leader and jog. There we go. Compiling makes them bigger. Okay. So I'm using yaw delta multiplied by -1 for the lean angle. And if we go to the event graph and go all the way back up to where the stuff that originally came with it is, we're getting the active rotation, we're getting the delta between that and the rotation last tick. Okay. And then we're setting rotation last tick. After we get the delta, so that makes sense. If you said it before, then you're just comparing the rotation to the rotation, not the rotation in the last tick. Getting the yaw from that and dividing it by delta time, and then dividing it by 7, which is lean intensity scaling, and then interpolating that current yaw delta to the target with an interpolation speed of 6 and setting the yaw delta. Okay, that's interesting. It's been too long since I've looked at exactly what multiplying and dividing by delta time does. I forget, I go back and I learn it, and then I forget it again because I barely ever use it. Okay, so I'm reading through chat here, so I stopped. I'm reading Ablu's message. Sorry if I mispronounced that. Yeah, so ALS, I think, does a lot of things really well. Unfortunately, I do not know much C++. I'm actually in the process of learning it. I've started going through a great book on it, Accelerated C++. It's an older book on the language. It's not up to date for the newer versions of C++, but it teaches it in a fantastic way. And I haven't really done much work with C++ in Unreal Engine yet. The extent of my work has been creating some math functions and blueprint function libraries. So I can create blueprint callable functions that take in variables and do calculations, but I can read some C++ and understand a fair deal, but there's still a lot I have to learn. However, when it comes to the blueprint version of ALS, maybe even the community version where things are replicated, I'm definitely planning on taking some inspiration and copying some techniques from that over into my distance matching video series where it's not a distance matching series, actually. It's going to be a much bigger series on advanced locomotion techniques with Unreal Engine 5. So let's see what this looks like. I actually have a controller here, but I haven't set up the input for the look up rate and turn right rate. I just have it set up for the mouse in this project. I'm using a joystick and a mouse. And yeah, I think the leaning is looking pretty good. Yep. It definitely adds a layer of fidelity to the locomotion. I think the feet are sliding during the loop, which is fine, because we haven't done anything to try to avoid that. Yeah, there is a bit of foot sliding there, but maybe not. It's doing pretty good, because I'm pretty close with whatever I set the character movement speed to. So, pivots. This is going to be fun. I'm also being half sarcastic. I've actually never implemented them before, but I've looked at a couple of other implementations. So let's go into our animations and I think they might call them plants here. No? Pivot? Okay. So I'm just gonna look at this jog forward pivot. As a disable speed warping curve, which will be useful once we set that up. A distance curve, which goes from a negative 315 to a positive 576. Okay. And as sync markers. So I'm going to try to take a pre-plant, post-plant approach with two states. One that will play the animation up until you get to the pivot point, that marker in the world, and then you'll transition to the post-plant state where you will play the pivot animation as you're moving away from that. And I think that is the approach to take. But first things first, I'm going to actually make a change to how I'm getting the start value and the stop value. No. You can actually, I came across it the other day where it makes perfect sense. You just do all the calculation inside of the update function and not the event graph, and you do it less. Because then you don't have to check these booleans each tick. But that had required me to refactor how I'm doing the debug stuff, so instead I'll keep the messiness here that and I will predict ground movement pivot location. It wants ground friction, velocity, acceleration. Okay, that looks like that's it. Is there an acceleration variable here that we're setting? Okay, not one that is a vector. All right. So we have this node here to predict a pivot location. But what we want to do is know when the character is going to pivot. What I think I'm going to do is I'm going to get a direction. I'm going to get direction. I'm going to create a new reel, which is what floats have been replaced with in UE5. Direction last tick. Or should I use acceleration? I'm going to try direction. I might need to use acceleration and a vector to do this. But I'm going to try with direction. So I'm going to get direction last tick. And I'm going to subtract that from direction. And now I'm going to well, I need to set direction last tick, which I will do after I do that operation. I don't want to set it from that. That was a mistake. I have to set it with direction. This will give me the difference between the direction, the current direction, and the direction from the last tick. And I'm just going to get the absolute value of this. I don't care if it's negative or positive. I'm going to check if this is greater than some threshold. Let's say 150 degrees, or let's do 135. And if that is true, I am going to get a do once, a reset when it's false, and I am going to actually, before I do anything else, draw a debug sphere. And the line color is going to be magenta. Duration 3 seconds. Okay. Let's test that out and see what happens. And it's gonna, yeah, it plays that montage and so I'm not seeing anything being printed, and that could be because it's doing it locally, like predict stop location, or it's not giving you a world location, it's giving you a location relative to the character. So let's try that bit of code there. I'm gonna unplug whatever in the animation blueprint is. Can we play this animation? Okay, still nothing. All right, so I'm gonna print a string. I'm gonna print this here. I do not want to print it to the log, just the screen. All right, that's it. I am unplugging. Actually, no, I'm going into character, heroes, Greystone player character. Where is begin play? I thought it was in here. Maybe I'm missing it. No, okay. All right, I'm just going to go into the animation graph and this slot. Not upper body, I think. Full body? Here we go. Yeah, I'm just gonna go straight from locomotion pose to inertialization. Compile that. And we don't have to deal with that montage playing every single time. That's interesting. I'm not seeing anything being printed. So did I make a mistake and plug that into a sequence that doesn't always fire off? No, that's going straight from the main sequence. So that's interesting. So instead of printing the string here, I'm going to print it here before I do that branch, and I'm going to give it a color that makes it easier to read, and I'm going to set its duration to 0. Now if I hit play, I see the issue. It's setting direction last tick before it's reading that value. I could fix that by setting a variable, but instead I'm just going to move set direction last tick to take place after. And I don't want to do it after I do the check. Alright, new variable. Direction. What are we going to call this? There's a technical term for the difference between two values like this on a tick, but I can't think of it. But I don't want to type out difference between direction and direction last tick either. Direction change over tick. That works. So I'm going to set direction change over tick. And I really need to organize this blueprint, and I'll do that off stream. Maybe after the stream today. And then I will set direction last tick. And then I will use direction change over tick. Here. Now, still 0. I think I saw it change though. It's only going to change for 1 tick. So let's use that branch again. And let's print a string in this do once, like we did at the beginning. And the string will be direction last tick. The duration will be 3. Ah, yeah, direction delta. That's the term I was looking for. There we go. Looks like it's detecting pivots. Yeah. Nice. I'm gonna try this on a controller because it's a bit easier to reverse my direction when I'm not on axis. It's 190. Okay, that was doing it. It's doing it in some situations. I think I see an issue with how I'm doing my logic. Maybe. Yep, it's definitely coming along since last time. So I think what's going on, if I just open this up and draw with my mouse. So, okay, that's bad, but so this is our 360-degree circle that is our direction. We have 0 degrees all the way around to 180 degrees. Then we have negative 180 all the way back up to 0. And so let's say I am going, what wasn't working was going from here to about here. So let's say right over here, we're looking at about negative 135 to 45, close enough. And so what we're doing in our blueprint graph is we are checking the direction and the direction last tick. We're getting the difference between those. And so we're subtracting direction last tick from direction. So we're subtracting negative 135 from 45, which is going to give us a number that's less than the actual difference. Our actual difference is 180 degrees. But if we subtract negative 135 from 45, we're getting a value of 90 something, I think. I apparently cannot do math in my head today. Nope. Yeah, we got 180 degrees. Why? If I would have written it out, I would have realized as soon as I saw that I'm subtracting a negative number. Don't mind me and my brain farts, guys. So, never mind that. This works. It gets me the yeah, that should work. When I subtract 45 from 130, that's negative 180, and then I get the absolute value, which is 180. So yeah, this direction change over tick is fine, or it should be. I'm gonna double check this again while I play. 180. 330. 354. That's interesting. In this situation, it's not really. Why is it giving me such big variables or values? Like direction is 45. I'm subtracting a negative 135. That gives me 180 degrees. If direction is 135, I'm going over to yeah, that's odd. I'm obviously missing something super obvious here in the math. Live on stream with people watching. So, what the heck is going on? All right, let's really look at this. We're going from a direction of 35. Our direction is at 35 or 50. Okay. and our direction is now at negative 132. So 50 to negative 132 gave us a value of 300 and something. That is not right. So we have 50. We should be subtracting direction from direction last tick. No. Still, exact same problem. So, okay. 50 to negative 130 something. So let's say 50 to negative 130. Close enough. That's giving us values over 300. It should not be, I don't think. So 50 minus a negative 130 is going to give us 180. So what is going on? Is it the direction last tick that's not the correct value? I'm checking if this is greater than 135. The direction variable is relative to the characters. Is it the control rotation? Might be. Yeah, it's relative to the facing direction of the character. So if the character is facing forward and they go from left to right, left is, the character is moving left, it's always going to be negative 90, right is always going to be 90. I just dropped my controller. Accident. I set it down on my lap and it slid off onto the floor. Set that back over here further away on my desk. So, I'm finding this to be really interesting. Something has to be going on here with how direction last tick is being set. It's being set from, oh. Yeah, it's being set from direction after I do this. So let's say direction is 180. Let's say the direction is 180. I set direction last tick to 180. Now, since that tick, this is the next tick, I've reversed my direction, it's 0. So I'm reading from direction, which is 0, and direction last tick, which is 180. And I'm setting this variable. Then I'm setting direction last tick to 0. And I'm moving on to the next tick. Nope, changing direction does not affect the reference frame. It's always relative to, the character is always facing the control rotation. The rotation of the character is being oriented towards the control rotation. So no matter what, forward is always the direction that I'm rotated towards. I can't rotate the camera around and look at the character, look at the front of the character, for example. And 0, the direction of 0 degrees is always going to be running straight away from the camera. And I can change my direction relative to the camera with my movement input. So I'm not going to spend more time trying to figure out why this isn't working, even though it's bugging me. I'm going to use vectors instead. I'm going to copy this bit of code. I'm getting the current acceleration and is it the dot product that I'm looking for? I don't think so. I could get the lookout rotation between the current acceleration and the acceleration. Let's see. My problem is that I forgot the details of exactly how the dot product works. So I can't remember if it does what I think it does. Dependent on the length of both vectors and the angle between them. I think we might be able to use the dot product here. There should be some logic. And -1 to +1 space. Awesome. Okay, so let's get... yeah, I was thinking it was something along those lines, but I wasn't remembering it was a -1 to +1. So yeah, let's get the dot product and use... we're getting current acceleration, and let's get acceleration last tick, I mean. And let's make that a vector. Let's set that. Let's give ourselves an acceleration vector as well. So I'll cut that. I'll leave that there and I'll set acceleration here. I'm not trying to be clean with this blueprint. I'm just trying to be fast so that people don't lose interest in the stream. I'll clean everything up for the video that I'm gonna make on this. Okay, so acceleration, we're setting that. Now let's get the dot product between acceleration, last tick, and acceleration. And now acceleration, last tick. I'll set that after I set a new variable named acceleration change over tick. And I misspelled acceleration here, which is why it let me make that a variable. There's already a float, so I'll make that acceleration vector. And now acceleration chain. So I'm gonna set, first off, this needs to be a float, acceleration change over tick. I'm gonna set that, and then I will set acceleration last tick from acceleration vector. Now I'm going to check if the dot product, this acceleration change over tick, is greater I'm going to check and see if it is. So it's a -1 to 1, so greater than 0.8. If that is true, I will print it and get the predicted pivot location. Okay, I think I need to normalize this. Yeah, I think this is gonna work. Let me try this with the controller. Yeah, there we go. Dot products, okay. Now that I actually remember how those work, I'm definitely gonna be making use of those more. That was very, very easy to do. Awesome. So now we know when we are pivoting. And if 1 is 180 and I want to enter, let's say, at 135, let me think here. So for -1, 0 and 1 would be I'll do that math later. For now, I think I'll just guesstimate it. Where am I checking that at? Huh? Huh? Okay, that's weird. Did I accidentally just delete that? I think so. It's funny. Alright. Let's put that back. I'll do 0.75. Or no, 0.5 would be... Yeah, I'll do a point... Yeah, 0.5, I think. Because it's on a scale of -1 to 1. And 0.5 would be -90 degrees if you're going from, so... yeah, 0.75. I'll stick with that. I think that's a good value. Alright. Yeah, because 0.75 would be it. Okay. Alright. So now... Considering my approaches, my options for how I enter into a pre-pivot and post-pivot state, I might just use this bit of logic here. So let's go here, and so from jog we can pivot. And from pivot, we can go into our pre-pivot, we can go into post-pivot. Then from that, we can go back into jog. Or, no, we can go back into jog. What if I stop in the middle of a pivot? That would be interesting. And what if I pivot from a start? Should I be able to? I could try to go ahead and pull up Paragon distance matching anim BP state machine. Let's see what comes up on Google Images. There's a PDF somewhere on the internet from one of the talks given on distance matching with Paragon that is a top-down view of the state machine. And I want to try to copy that. once I find the PDF, I'll share the link in the live stream chat if I can find it. Alright, well, I'm just gonna go to the YouTube video. Bringing a hero from Paragon to life with UE4. And if I scroll through here, I'm doing this on my other screen, by the way. It should show their state machine, their anim, that part of their anim graph at some point here. I'm just trying to remember where. Maybe they don't. Aha. Okay. Their locomotion state machine has a locomotion idle. There's turn in place stuff. There's stun. There's knocked back. There's jump. There's locomotion start, which can go into a locomotion loop only. And from locomotion loop, you can go into locomotion spin. You can go into locomotion pre-pivot from locomotion loop. And you can go into locomotion post-pivot from pre-pivot. You can go back and forth between those two, but then you can go from post-pivot to locomotion loop. Locomotion stop and start cannot get into the pivot states. Okay, that's what I was looking for. So, and let's create 2 new states. Pre-pivot and post-pivot. Jog can go into pre-pivot, pre-pivot can go into post-pivot, and post-pivot can go into pre-pivot, and post-pivot can go back into jog. All right. Now, to figure out the transitions. We know that we are going into pre-pivot if our, not copied anymore, if acceleration change over tick is greater than 0.75, and I think, so I don't have this code duplicated and where the variables could end up different, I'm going to create a boolean. Name it should pivot. And I'm going to set it to true. Based on this condition, actually. And I'll set it, I think I can get away with setting it before the branch. If not, I'll set it true when the branch is true and false when the branch is false. So now, let's go back over into this transition. And if should pivot is true, it'll transition from jog to pre-pivot. And I'm going to set that duration as 0 for the time being. And I think I'll do the same for post-pivot to pre-pivot. So now I'll promote that to, and I'll use pre-pivot in 0. And now to go from pre-pivot to post-pivot, we know that we are moving towards the marker. So when we're moving away from the pivot marker, we know that it's time to transition from pre-pivot to post-pivot. So let's get, why did I go all the way out into the anim graph? Now I just want to go over to my event graph. And we have this value right now. All we're doing with it is that we're doing some debug stuff with it. I'm going to move the debug stuff that we do way over here. And I'm going to get my debug branch with my debug boolean and plug that in. Now I'm going to move this over here too. I only need it for the debug. I'm going to promote this to a variable, and it is going to be pivot location. And I have a bunch of variables from that. I'm trying that with direction instead of the dot product that I need to delete, but I'll do that later. So from the do once, I will set the pivot location. And then I can use pivot location over here for all of this stuff. That way I don't have that line. Why is this search window up? Can I get rid of that? All right. Okay, so we have our pivot location. Now we just want to get the the distance to it, so that we know when we get there. There's a couple of different different approaches we could take. Maybe we might be able to pull this off in one state. I wish I knew why Paragon split it up into two. They undoubtedly had a reason to do it. But I don't know exactly why that is. It seems like it would be easier with... I see. You could leave the pivot from another direction. You could change your direction while you're still... maybe that's it. I don't know. I guess that could be it. Yeah, pre-pivot you treat like a stop state because that's what it is. Post-pivot you treat like a start state because that's what it is. That's why. Okay, that makes sense. So we can switch from pre-pivot to post-pivot. Would there be a point where acceleration is 0? I'm curious to see if that is the case. You're switching directions, and depending on, and it generates a stop location before it generates a pivot location, but does it do that in every instance? Yeah, it went into pivot, which is nothing and no way of getting out. So let's try and see if we can do this with an acceleration equal to 0 for this transition. I don't think it'll work, but it would definitely be the easiest way to do this if it does, so I'm going to give it a shot. Where is acceleration? It's over. I'll just search it. Here we go. Acceleration. If acceleration is... Did I say? I've probably been saying greater than 0. I mean nearly equal, not greater. I apologize for that. And then post pivot goes into jog. When to start going to jog? It's an automatic rule. Okay. Okay. And if we get into post pivot, let's play an odd animation that we'll be able to tell we're in post pivot without setting up our whole state. Can we do like some jump thing? Jump apex. And we do not want to set this to loop. That's important. And if we're on pre-pivot, let's do jump recovery. And again, I just want to be able to tell really quickly here for this test if that transition works. Because if the transitions aren't working, I do not want to try setting up the state. Okay, something's going on there. Let's make sure we have our debug stuff plugged in. So we do not. So there's a pivot. Interesting. All right. So let's go back over into our pre-pivot state. And let's not worry about transitioning into post-pivot yet. Let's delete that transition. You can go to pre-pivot and you get stuck in it forever, which is fine. And now we are going to copy our start state and paste it in. Now, instead of, okay. The more I do, the more things I see that we need to do. Because orientation angle is not going to just work here. Is it? I don't think so. I mean, maybe for pre-pivot. Maybe it will. Let's try it. And maybe it will for post-pivot because we split them up. So let's do... We have to know what animation we're playing. And if our orientation angle is backward, we know what direction we've come from because it's the inverse or close to the inverse of what we... Yeah. 135-degree difference. So, yep, okay. So we should be able to just put in our pivot animations here. This should be forward to backward. So jog forward, pivot 180, I think. Let me double check that. So jog forward, pivot 180. So we start going forward, yep, okay. So this should be jog right, pivot 180. Or should it be? No. This should be jog backward, pivot 180. And this should be... jog left, pivot 180. And I keep not trying to double click. I don't know what's going on with my mouse. This should be jog right, pivot 180. And finally, jog forward, pivot 180. And what we need to do is we need to go into our event graph. And Okay, what we're going to do is we're going to get this pivot location. We're not going to do this in our event graph. We're going to bind, we're going to create a new distance matching function. And duplicate distance matching start. I'm going to name it distance matching pre-pivot. And instead of using start distance, I am going to get our pivot location. I'm going to then get our location, and I'm going to get the distance between the vectors, and I'm then going to get let's see if that works. And I should have used copied stop, but the only difference now is that I'm not multiplying that by -1, I think. I think that worked. It's hard to tell. No, it didn't work, because we would not be able to escape the pivot animation and the pivot state. We'd be stuck in it forever. So if should pivot is true, we should go to pre-pivot. And we'll see that so once we're in pre-pivot, we should be stuck playing these pivot animations, and we should not be able to escape. So, all right, maybe we are. Yep, we are. Because if yeah, yep, we definitely are. Cool. So that worked. So now post pivot, let's do let's try the acceleration equals 0 thing. Let's see what happens. No, it's not, because if we could go into post pivot, we'd play no animation. So let's go for distance between, let's get the location and the pivot location, and let's get the distance. And if the distance is nearly equal to 0 with an error tolerance of 0.01, we enter into post pivot. I don't know if I'm actually in the pivot state. I don't know what's going on here. I need to figure out how to debug this. I need to know if I'm actually in pre-pivot. Let's do a jump apex and pre-pivot. That'll be easier to see. Now let's, yeah, we are not transitioning. Because we're in the stop state. Yeah, you can. There's a couple of steps you have to take, though, I'm pretty sure, to actually show it. Let me see. I think it's because we're in the stop. Yeah, we're in the stop state before we're in the pivot state. You can put it in the other window, but there's a series of menus you have to go through to actually set it up so that it shows it in real time. I don't remember what those are. So we have to be able to pivot from our stop state, not from our jog state. Paragon might have had some extra logic in there that made that work, but we don't. So we need to be able to go from stop to pre-pivot and post-pivot into jog, but not yet. So jog to, so stop to pre-pivot, and that should use shared pre-pivot. Set that to 0 now and delete this. Now we're in our stop state and we go into our pivot state, except we don't. So what logic am I using to go from stop to pivot? Should pivot, okay. And should pivot is going to be true when acceleration over tick. So let's switch this up. Let's set should pivot to true on the let's set it to true here. And let's try to leave it on until, I'll just set it to true and see if we can get into it to begin with the first time. Before we even pivot, because I mean, we know that's working because it predicts it. It predicts the pivot location and it's accurate. And it's only printing it once at the right time. So all this happens at the right time. Or simply the real question is, can I get away with this without the do once? If it works how it should be working, it shouldn't even need that do once. Now it's going to try to predict the pivot location every tick, no matter what. But it's only going to do that if should pivot is true. It'll only print if should pivot is true, and should pivot is true. An acceleration chain, delta change. That can be confusing. Or dot, not delta. Acceleration dot. We're getting acceleration last tick in the acceleration vector, and that's acceleration dot over tick. And from that, after that, we then set our acceleration vector. So each tick we have an acceleration dot, a dot between our acceleration last tick and our acceleration vector. And that acceleration dot, that change in direction, if it's greater than 0.75, if that is true. Alright, I'm gonna not draw the sphere. I am going to set the duration to 0 on this. I just want to see what that dot is every tick. It's 1. Why is it always 1? because the angles line up. So am I using the dot product wrong? That could be it. It briefly doesn't print when I change directions, when I pivot, but then it starts printing again. So am I doing this backwards? Should it be the other way around? The current velocity and the input acceleration. All right, thanks, Ryan. I'll try that. And what do you mean exactly when you say input acceleration, though? Okay, so the acceleration is calculated by the character movement component. Okay. So current velocity and the input acceleration. So let's get our velocity. Do we have that as a variable here? I'm not sure. That's fine, I'll just get it here. No, they're not throwing me off. If anything, they'll help because what I was doing wasn't exactly working. And now I'm just going to take this. I'm just going to print it here and read the value. And do nothing else right now. Yeah. Alright, that's a large number. I need to normalize. I guess I need to normalize these. And I don't want to grab. I'm printing out too many things, so I'm going to use an append here. So once it goes negative, oh, that's interesting. If that's a negative value, I've switched directions. Okay. So let's say if this is less than 0, I'll set should pivot to true. And then I will do all this. But I have to do it on a do once. Yep, and I enter the pre-pivot state. So now if I go to pre-pivot, I'll plug in this. And I do have my animations backwards. Okay, no big deal. Forward should go into backwards. Backward should go into forwards. Right should go into left, and left should go into right. There we go. Look at that. And that's without the post pivot state. It's actually working quite well without that state, which is interesting. So I'm gonna try going straight from post pivot, from pre-pivot to stop and to jog with automatic rules. Or when acceleration, oh yeah, stop won't be an automatic rule, it will be stop. All right, well, the stop transition isn't necessarily working well right now, but there's some weird orientation warping spins, but I'm not focused on those right now. I'm focused on stopping from the pivot currently. So I'm in the pivot, and if acceleration is nearly equal to 0, I go to stop. And I never set should pivot to false, because acceleration instantly equals 0. So another thing here. Okay, currently I don't think I am blending between states. Maybe I am. The duration of the blend from stop to pre-pivot is 0. Then pre-pivot to jog, I'll take that to 0 as well. And I'll also do pre-pivot to stop just to make sure we don't have any blending interfering with any of those transitions. But so this should pivot, I stop, and should pivot, I guess, never gets set to false. So okay, that's odd. That should be what's set the pivot location. That was really weird. That wasn't distance matching, I guess. So I'm in pivot and I stop. Interesting. And it's because of this. So I guess if acceleration, so I'll do if acceleration. All right, so I'll get an and here. No, that shouldn't have anything to do with the transition. Even though should pivot is true, it should still be able to stop. Stop goes back into pre-pivot. I see. Okay, that does make sense. So if so, we get an and. So if this is greater than, no. Acceleration is, I'll do that nearly equal to 0 and get a not. I'd probably be safe doing a just equal to 0, but keep getting the wrong node here. There we go. Still not. All right, so I won't do this here. It should be 0 when I stop, so should pivot should be false. When I'm trying to stop. So let's get an append. Let's read that as we play. And let's make sure we set our duration to 0. Should pivot false. It's true. It's false now. True, false. I should be able to stop. True, I'm in the pivot. False, I stop. Did I not compile? It seems to be working. Except that didn't work. So we are not stopping. Are we staying in that pivot? are transitioning from where? Alright, there's my MVP. We're transitioning from pre-pivot to stop. We should be, but we're not. Or stop isn't, or it's that, or stop is immediately going back into pre-pivot, but should pivot is false when we're stopping, or it should be. Yeah, it's false. We just left the pivot state because there's no blending. I saw that. It's, yeah, we stop, we freeze. Why do we freeze? If anyone has any ideas, let me know. We have 20 minutes left in the stream today. So we go from pre-pivot to stop when acceleration is nearly equal to 0. We know that this transition works from start, from jog. So are we going into stop, and is something being messed up with the distance matching? Let's try distance matching on become relevant in this state. Enter it, and does that break it? No. Oh, I wonder if I'm doing that. Yeah, on become relevant, then we're doing a distance matching. Start, we're not doing our distance matching pre-pivot here. Huh. That's important. That's interesting. So maybe I didn't have these backwards. First pivot seemed like it worked. The second one doesn't. Honestly, I was expecting to run into more issues than I did, so it makes sense that it wasn't even distance matching that. Let's just try multiplying that by -1. I don't think that's the issue. I think that because if these start with negative distances, then alright, so I want to treat, if I'm treating this as my single pivot, then I'll put it in like that, because I'm just using a single pre-pivot state right now. I'm going to add a post-pivot state in if and only if I absolutely need it. So we get the distance between the location and the pivot location. How do we do our starts? our start distance. So let's look at this. We're moving backwards. Our distance curve starts from a negative number. And it goes up. So we do not want to multiply this by a negative value in our pre-pivot state. We want to use it as it is. Weird. Oh, okay. Yep. We're not using uniform indexable curve compression. Gosh, I should have thought of that sooner. Still didn't fix all the issues. Our distance would be increasing at that point, which would mean that it would want to play it. Wait, no, it starts at a negative value, which means that we would want to multiply it. I got that backwards. It needs to be, I'm not trying to create a new local variable, UE4 or UE5. It needs to be multiplied by -1 for the node to work correctly with this. I don't like that transition. It just doesn't look nice. Let's look at this in slow motion. We're in our start state. Into our stop state. Now into our pivot state. And it won't work in slow motion because of how we're getting our values. UE5 handles, actually, when you go into slow motion with Unreal Engine 5, sometimes I notice the input also goes in slow motion. Okay, now the pivot's working though. So that was an orientation warping thing. A blend. Not a blend, but I'm going to pull... I'm going to bypass the orientation warping temporarily in this state. Alright, I want to do a bit of a blend there. I do not like the distance matching here. Is it even distance matching? That's the real question. Let's think about this. Let's look at our distance matching stop. We just are getting our stop distance, our distance of which is updating each frame. And then our pre-pivot, or pivot, is location, distance between location, and pivot location. So that's going to go down to 0, then up from 0. As it goes down from 0, pre and post pivot do need to be another state because of this. Okay. Okay. But we're not even really... I'm tempted just to try to treating that as this as a post pivot. And so if I treat it as a post pivot, that would mean that that value that increases, it starts at 0 and it goes up from there. But with a stop, the distance curve starts and goes up to 0. I mean, treating it as a start, post pivot, so treat the whole pivot state as a start state. So with the start, the distance curve starts at 0 and goes to a positive number. And after a certain point, that's what this does too. And we multiply it by -1, just like distance matching start. So I think we can get a... I think we can do that. I think we can do that. And if this pre-pivot is just a post-pivot state, it's funny that it looked better when it wasn't distance matching, except it was distance matching from the start location instead of the pivot location, which worked 9 times out of 10 when it also registered a distance matching start during the pivot. In a case like that, it wouldn't work though. I'm going to do distance matching start, just to see what happens when I match from the starting location. Won't work every time, but it will work some of the time. It goes backwards, which we, I think, can fix by going into... It's gonna mess up our starts, but I just want to see what happens. Oh, okay. Keep that there. So if we use our start location, things flip around, which is weird. So I'm at a loss as to how to get this working right now. We're 5 minutes away from the end of the stream, so I'm going to end it out here, guys. And by the next, and one of two things will happen. Next week we'll continue with this project. I'll have figured some stuff out and I'll have fixed it. Or you guys will see a video on setting up distance matching with Paragon characters. Depending on how long it takes me to fix it, I might get to another, depending on where I'm at in that process, I might do another stream with Paragon characters, or I might do just make the videos in between. And if I get this figured out, and if I do get this figured out, there will still be a stream this next Friday. It will just, I think, be, I want to play around with some of the new IK rig stuff, so maybe that. So unfortunately couldn't get pivots all the way figured out. We are predicting pivots though, and we're getting that location. It's not the cleanest blueprint code ever, but it works well enough. So I'm gonna look at some other distance matching implementations, how some other people do it with plugins, stuff I didn't get around to before this stream, and then I'll come back around and see if I can get this figured out in time for the next stream or in time to make a video on it. And speaking of videos, my next video should be out sometime this next week. I ran into a series of issues recording it. I had to record it twice over, but the second time where I started over, my screen stopped recording a couple of minutes into like recording that was over 30 minutes, and I didn't even realize, and so I had to record it a third time. And so the recording's there, I just have to edit it and post it. So next week you guys will have a new video, and it's not animation stuff, it's world partition and landscape stuff. But then we'll get back, hopefully by that point I'll have this figured out and I can start putting out Paragon distance matching videos. So thanks guys for sticking through the stream. I hope you found something useful in it, even if a lot of it was me struggling and trying to figure things out. And I'll see you guys in the next video or stream. Thanks for watching.